All right, so now we're going to move on to preliminary section 2, statements and reasoning, which is the beginning of logical processing for geometry. So a statement is a set of words or symbols that together will make a claim that is either true or false. Statements are either true statements or false statements. So let's look at some examples here and determine if something is a statement and whether it's true or false. So 4 plus 3 equals 7. That is a true statement. An angle has two sides. Well, here we haven't really talked about angles yet, but here this diagram is obviously forming an angle, and we can see by that picture, that diagram, that yes, an angle does indeed have two sides. So that is also a true statement. Robert E. Lee played shortstop for the Yankees. Well, unless there's a Robert E. Lee that we don't know about, that is not what Robert E. Lee did. We would say false. Robert E. Lee was not a professional baseball player for the Yankees. And here we have some math symbols. 7 is less than 3. The arrow always points to the smaller number. So this is read as 7 is less than 3, which is not true. 7 is greater than 3. So the statement, 7 is less than 3, is false. And then how about look out? That's not even a statement because it's not true or false. It's not even a statement. So we're going to be dealing with statements, different types of statements, and then we're going to be dealing with arguments using statements. And then sometimes a statement will contain a variable, which is a lowercase letter that will usually hold a value. Like an example of a statement might be 5x is less than 30. Is that true or false? Well, that will depend on the value of x, won't it? It could be a true statement, it could be a false statement, depending on what the variable x contains. And the negation of a statement makes the opposite assertion. So if the original statement was true, then negation is false. If the original statement was false, the negation is true. And this symbol is the not symbol. So if I had a statement, we'll give it the name P, that says, my house is blue. Not P, the negative of P, not P, is my house is not blue. And I'm not saying what color it is, I'm just saying it's not blue. So let's say originally, now my house is actually gray. So my house is blue, that would be false. So the negation of that statement, my house is not blue, you know what? That one would be true. So that's how your negations work. Now, these are simple statements, but we can also have compound statements where we put two or more statements together. We use the statements as building blocks, and because of that, we're going to give each statement an uppercase letter to signify it. Usually it's P and Q, and you go right down the alphabet. You'll see statements R, S, T, U, V. They start down there at the end of the alphabet. So, for an example, if we said P was the statement 4 plus 3 equals 7, and we said the statement Q is Babe Ruth was a U.S. president. How could we put those together? Well, we can put them together as a conjunction or a disjunction. A conjunction will have an and. P and Q. That's your conjunction. Your disjunction will have an or. P or Q. That's your disjunction. And a conjunction and a disjunction will also have either a true or false meaning. It'll be asserted as either true or as false. And that will depend on whether P and or Q are also true. So let's see how we're going to put these conjunctions and disjunctions together. Here's an example of two examples of truth tables. So we have a column for P, and we have a column for Q, and then we have a column for P and Q. Both P and Q have to be true. So what I have is I have a row for every combination of P and Q being true and false. So P was my statement that 4 plus 3 equals 7. For the ands, for the conjunctions, both P and Q have to be true for the conjunction to be true. So, if I have 4 plus 3 is 7, that's true. Babe Ruth was a president, you know what, that's false. So, my and would be considered false. For an and, both P and Q have to be true. But for the or, for your conjunction, either P or Q can be true. Again, we have enough rows for every combination of P and Q being true or false. But for your conjunctions, just P has to be true. As soon as P is true, we know the disjunction is true. As soon as P is true, we know the or is true. Here P was false, but Q was true. And then, if of course, if both P and Q are false, then the disjunction is going to be false. So if P, then Q, this is, we're on to a different topic here. This is known as a conditional statement or an implication. So if P is true, then Q is true. That's a conditional statement, and that whole statement is either true or false. Another way to write if P then Q is all P's are Q. That is another way to write a conditional statement, and that is either true or false. So let's give an example. I'm going to say if a girl has a child, then she is a mom. A girl has a child is P. She is a mom is Q. So if a girl has a child, then she is a mom. You know what? That's a true statement. That's a conditionally true statement. How about if a girl has a child, then she is pretty. That's also a conditional statement. A girl has a child would be P. She is pretty would be Q. And is it true that if a girl has a child, then she's pretty? No, that's the condition for being pretty is not having a child. So that would be considered, that whole statement would be considered false. We could rewrite this as all girls with children are moms. All girls with children are moms. You know what? That would be true. These are the same statement, just written a little bit differently. But if I said all girls with children are pretty, that is a conditional statement, but it is not a true conditional statement. It is not a true conditional statement. It's actually a false conditional statement. So in these conditional statements, the statement that follows the if is considered the hypothesis. The statement that follows the then is called the conclusion.